Hi, folks. How's everyone doing? You guys are still here, day 3 p.m. Really appreciate that. So I'll try to make it short and sweet. So my name is Dhruv Goyal. I'm a PM on the Azure Big Data team. And I'm here to talk about ingestion with Managed Kafka Clusters in Azure HDInsight. So if you're not here for the right session, maybe you want to check right now. So quick agenda. We'll go a little bit of an introduction into Azure HDInsight, what it is, and how you can get managed Kafka clusters with Azure HDInsight. We'll talk about a bit about customer examples where we have seen a lot of success. I'll do a quick demo on how to set up an ingestion pipeline with an Azure HDInsight, and a quick sneak preview of one of the features that we are working on. It's going to come out soon. And time permitting, we'll have Q&A at the end. So jumping right into it. First of all, how many of you have heard of HDInsight? All right. Couple people. How many of you have heard of Kafka? Great. That's awesome. How many of you have actually set up a Kafka cluster before? OK. So you know what I'm talking about. How hard or easy it is for you to set up your Kafka clusters. Are you doing it on-prem, or are you doing it on the cloud? On-prem? How about you? System setup? OK. So a wide variety here. So what Azure HDInsight is a managed cluster service where you can have a lot of different types of open source clusters created for you with a click of a button. So you can have open source components like Spark, Hadoop, HBase, LLAP, Kafka, Storm, all of those created in a very easy manner. What HDInsight provides you is a service-wide SLA, a 99.9% guarantee, not just on the VMs, but actually on the entire service. You get out-of-the-box OMS integration. Developers get really rich tools for developing with Visual Studio, IntelliJ, Eclipse. So it's a really rich environment for data scientists and data engineers. The biggest thing we see with our enterprise customers is the enterprise-grade security that they want, the Kerberos, authentication, and integration with Apache Ranger. And finally, it's so easy to extend your clusters with ISV apps like StreamSets, and many others that basically enable you to extend the functionality of your clusters. So by the way, we just announced a price cut, and now it's 50% lower than what it used to be before. So it's even easier for you and cheaper for you to justify that decision to run these clusters on the cloud, which is much more scalable. And before we actually did the price cut, we had a Forrester study, TCO study, which showed that running Azure HDInsight clusters compared to on-prem saves you 60 to 70% of your management costs. So just a shout out to Alina Hall. She's there in the audience. She did a great session yesterday about Apache Kafka and Spark. And that one goes a little bit more into details of Kafka brokers and Kafka topics. So if you want a Kafka one-on-one on how those things work, you should definitely check that out. So what does Kafka do for you? What does it really enable? And when you're thinking about Kafka, you hear about this technology. What can it do? What Kafka is basically a streaming engine, a streaming platform, rather. And that enables a lot of different applications. You can think about real-time fraud detection. Someone swiping a card, making sure that it's your card or it's someone else's card. You can't wait for that decision to happen 5 minutes down the line or even 10 seconds down the line. That decision needs to be made in real time. You think about all of these IoT things that you're seeing today, a lot of them are based on real-time ingestion services to make sure you are gathering those insights in real time, really quickly. Clickstream analysis from your customers. We have e-commerce customers who have their websites based on the behavior of the customers and want to make sure that they are giving the right offers to those customers, and many others. So we can go deeper into any scenario we want, but just a wide variety of real-time analytics that's enabled today. What Kafka for Azure HDInsight gives you is then you get the service level SLA that you get, but you get other stuff like integration with Azure Managed Disks. One of the biggest things I think you might have seen during your on-prem installation of Kafka clusters is that the data is really stored on the VMs that Kafka is running on. And what that means is when you have more throughput coming in, more data coming in, you have to add more VMs, and that adds to the cost. With integration with Azure Managed Disks, your compute and storage is separate. So you can scale your compute and storage independently, and it reduces your costs exponentially. You can get clusters. I mean, really quickly, just this kind of shows you On the right, the image shows you the UI that you would go through to kind of just set up a Kafka clusters very quickly. We have rack awareness built for Azure environments. So Kafka only comes with a one-dimensional rack awareness. Azure in the data center itself has something called update domains and fault domains to give you even better, higher availability. We are aware of that and making sure that your VMs are never across the same update domain or the same fault domain, just to make sure everything keeps running. Again, the integration with the OMS and extensibility with stream sets and other different applications, some of them listed over here, such as DataMir, DataIQ, H2O, just gives a lot of functionality to you to make sure you're just not getting a plain vanilla Kafka cluster, but a lot of extra out of it. And we support disaster recovery through MirrorMaker. And one of the biggest things about HDInsight is that you get your own secure VNet that you can lock down in any way you want. You can just say, a lot of our customers have security requirements where nothing can be coming in. They don't want to expose any public endpoints, stuff like that. And the way you do that with HDInsight is through VNets, and you can have other clusters besides Kafka in the same VNet, such as Storm or Spark. So what that basically then enables is you to create this modern data warehouse. A scenario in that is real-time analytics, where you're getting structured or unstructured data coming into Kafka, and then it can pass it on to Databricks Spark or HDInsight Spark. You process that, and you can send that to a visualization dashboard, or you can send it to SQL Data Warehouse and have interactive queries on top of it down the line. So that's just like an example enterprise architecture that could be enabled through that. So how would you get started with it? So it's really easy. You just set up a VNet, and you create your Kafka cluster within that. And the Kafka cluster is really easy to set up through the portal. Those are some steps. You can do it via ARM templates or scripts. Once you set up the Kafka cluster, what you need to do is create topics for data coming into those topics. And in this case, a topic is basically how Kafka distributes data across different consumers and producers. So for example, if you're talking about connected car scenario that we'll talk about in a bit, you might want topics which are cars located in North America or cars located in Asia and different countries, and topics for data coming in for those things. And the biggest thing about Kafka is the producer and the consumer APIs are actually super simple, right? This is something written in Spark, and I'm actually going to go through that in the demo. You don't really have to do many things. Only things you have to do is kind of set the properties of the Kafka cluster, where you say, hey, this is my Kafka broker, and then you just send messages to it. Similarly, when you're reading from a Spark application, you can just say, hey, this is my Kafka broker, and I want to read from it. And you will see how similar it is to any batch job as well. So with that, a couple of examples. I was talking about the connected car architecture, and what we are seeing with some of our customers today is they have these IoT devices within the cars. They're sending signals as the customers are running those cars, and that with those signals, the companies can then process on how the cars are doing, how fast they're going, and try to do preventative maintenance for those cars. Send them signals on, hey, you need to come in for service maintenance. And the way that happens is that data is coming in real time into Kafka, and then they process it with Apache Spark or Storm within the same VNet, and then they can either store it in cold storage, or then they can pass it on to real-time dashboards, Power BI, or anything else that you want. Another big use case for us is something called Siphon, which is an internal Microsoft team, and what they do is they act as an ingestion service bus for a lot of different teams within Microsoft, such as Office 365 and Bing. And the amount of throughput that they're seeing through their Kafka clusters today is amazing. They're seeing 8 million events per second of peak ingress and 800 terabytes of data a day. So just the biggest aspect of Kafka is that how scalable and how much throughput it can handle very easily. And it has the super low latency within it. So with that, let's do a quick demo. Actually, I'm going to use a really simple demo that's also available on our docs website. And what we do in this is we are basically reading from a data set and then writing that to Kafka. That's what the Spark cluster is doing. And we'll have Kafka then streaming that data back to Spark. So this is kind of the setup of that. And you can try out these demos super easily on from Microsoft Docs website. What we have is a custom deployment template, and all you need to put in there is the Spark cluster name and the Kafka cluster name you want, and the login username. And that will create the HDInsight cluster for you. So I got that part set up before we started here so that I can just show you what happens after the cluster setup is there. So within this resource group, as you can see, like it has that deployment template set up the Kafka cluster, which is this one right here, and then the Spark cluster, which is this one right here, and a bunch of other things just to make sure that, I mean, when you set up the VMs, they're part of your cluster. So if you go and look into the Kafka cluster, you'll see that it has 9 nodes. It has a few head nodes, worker nodes, and Zookeeper nodes. So once we have that Kafka cluster up and running and the Spark cluster up and running, this is a Jupyter notebook that comes inbuilt with Spark clusters and HDInsight that helps you basically write simple Spark queries or do a data science kind of scenario. So what I did was, all you need to do is put in your cluster name /Jupyter, and you upload the notebook that comes with it. And that's something that's provided in the demo. So you can go and upload that into your Spark notebook, into your Jupyter notebook on your Spark cluster, and you open that notebook up. So as part of that Jupyter notebook, the first things we're doing is just basically setting some configurations up to load the right libraries for Spark and Kafka within that notebook. And then I'm going to be setting up a topic on which, like I was talking about before, any data that comes in gets loaded into that topic. A few key things that come into play when you're defining a topic is the replication factor, the number of partitions that you want to have, and the topic name. The remaining stuff like Zookeeper, you just provide it so that I can connect to the right Zookeeper, right Kafka cluster. So just to show you what was created before, this is the list of topics that I have in my Kafka cluster right now. So you can just simply query that with a simple shell script. And then you can see how the topics are distributed. Since I created it with a replication factor of 3 and 8 partitions, each partition is basically replicated twice across your Kafka cluster. So that gives you super high availability. And it also puts it on a different VM. So in case any VM goes down, your Zookeeper selects the next level, the next leader for that partition, so that your streaming application can keep working. It does not go down. What it'll do then is Azure will give a new VM, we'll replace the VM, and it'll copy over the data from one of the existing follower partitions into that new partition. So this is what, once you set up your topic, it looks like underneath. So let's go back to the notebook. And in this notebook, what we're going to do is retrieve the data from taxi trips in New York City in 2016. So this is a simple Spark data frame that gets loaded. It connects to this URL, loads that data up, and then it's going to show that. So you can see that the kernel is spinning, and that's running the job in the background. And boom, you have that data in that data frame. Next step, you kind of just provide the information regarding the Kafka brokers in the topic. So you have to do a little bit of that setup, and you can start sending data to Kafka. So once I do that, and I've done this like 4 times before, so there's already some data in the Kafka topic. This is going to add data to the topic. You can see that data is already there. And just to show you, what I'm going to do is actually read from the Kafka topic. This is a simple console consumer. You can actually also read data from Spark, which we're going to do in a bit. But this will show how quickly it has gotten all that data already. So if I end this, because this is a streaming job, it doesn't know where to end. It has 6,000 messages because I have run it six times before. I can run it again. It will send the data again to Kafka, and we'll see how quickly it's getting that data. So by the way, this was the Spark cluster we had running, and now it's sending that data to Kafka, and Kafka already has that data. So again, if I end this, you can see 7,000 messages. So it already got all the new messages in there. So what we're going to do now is read from Kafka in this Spark cluster. We define a schema for the Kafka, and there are 2 different types of queries you can do in the notebook, the batch and the streaming. I'm actually going to show you the streaming one because that's more relevant here. And it's so just to show an example of what a streaming query looks like here. It's really simple. It's actually very similar to what a Spark batch query might look like, but you read, instead of doing a read, you're doing a read stream. And you say the format is Kafka. You provided the bootstrap servers, which were the Kafka brokers, and you subscribe to that Kafka topic. the starting offset basically specifies how far back do you want to read. So you can read from any point in that Kafka topic, and then you load that streaming data frame. So now that you have the Spark data frame, you can just select, and what this query is actually doing is writing it to cold storage. So that could be one of your scenarios, is you're writing, connecting to any cold storage and writing back to that. Once it does that, it'll give me some idea of when that's done. And then we can look at the files in that Hadoop distributed file system location to see if we have those files. So the Jupyter notebooks, you can see the Spark kernel is busy, so it's running that job. It has 7,000 records that it needs to write in there, so that probably takes a bit of time. Actually, the time it takes is also because of this, 30 seconds. Because it's a streaming query, it doesn't know when to end, so you basically tell it, hey, end after 30 seconds. I hope that made sense. If you guys have questions, I'll stick around afterwards to answer those. And now you can see that the notebook shows, hey, these are the files that I kind of wrote to your cold storage. And since I've done this a few times before, it has more files than what we wrote just this time. OK, so that was just a quick demo. What I also wanted to show you, let me switch to the input here. Like one of the things that our engineering teams is working on, and the challenges we get with our customers, is Kafka clusters are usually long running, and you want to make sure that any hot fixes, patches that come up, you don't have to kill the cluster and start it again. And with the managed PaaS service, that is kind of what you expect. So what you're going to get now is this rolling upgrade feature, with which whenever a new version comes out that's backwards compatible, and this is kind of showing you the Ambari UI for that, you could just go into your portal and say, hey, I have a Kafka cluster running on this version. I want to update it to a next version. And then it'll stop one broker at a time, one zookeeper at a time, and it's going to check and make sure that everything's running. It's going to do a service check, and then it's on the Kafka. If that Kafka broker is running fine, then it's going to roll and do the upgrade on the next one. And it gives you an option to finalize the upgrade. It doesn't actually force you to go through with the upgrade. If things are not working correctly, you can say, hey, hold on. Let me just roll back to the previous version in production and not break my production pipeline. So that's something that's in the works, and it's going to come out soon. With that, I think I ended up really quickly. So I have 3 more minutes left. There's a lot of resources over there that you can check out and find more information about Kafka, about HDInsight, how to create streaming pipelines, how to learn more about different streaming sources. And like I said, check out the presentation from yesterday, which was about creating pipelines with Kafka and Spark. Cool. Any questions while I'm here? Anything that I can answer right now? Otherwise, I'm also available afterwards. Great. Thank you all for your attention. Really appreciate your time. Have a good one.